Hi guys, so today I'm going to try to address the potential for these cameras to drain the battery. I think I have two dash cams here. I like them a lot, but when they're running in parking mode, they tend to suck up a lot of battery, and I've had issues with my battery, which was 5 years old. It's already on its way out, but it died, and then it was also impacting the alternator, which couldn't keep up. So the alternator died after 23 years of running. So it's hard to know whether it's the age of the alternator or it was pushed over the limit. So I don't want to have to replace the alternator again or a new battery in a couple of years when my previous battery lasted 8.5 years. All right, I always have a trickle charger here, so I'm always taking care of the batteries. So here's what I ordered from Amazon. I want to show you how you can measure the amperage, milliamps or amps that your different components are drawing. And these two cables should help me do that. So now the thing is, as you know, the battery's in the back in E36, and I want to be able to read the multimeter in the front while I'm disconnecting the fuse box. So that's why I decided to get some nice clamps that I can hook up to the battery in series. And at the other end here, I have these that I can connect to the alligator clips that I got here. So this is going to be interesting. We're going to see how we're going to do that. Okay, so let's get to the battery here in the back. What we're going to do, we're going to open that up. And now the key here, of course, you can always remove this and break your circuit. So which means that you have to reset the clock, you have to reset everything. Now in this car, because it's an old car, that doesn't matter. You can easily do that. But, there's a way to do it without having to lose battery power to the vehicle. So let's try this. I'm gonna try to do it. All right, so here's the battery terminals, and I'm going to essentially open this connection without breaking the electrical contact. And for me to do that, I'd have to short them with a wire, perhaps a copper wire, and I try to wrap it around that battery terminal. Okay, there you see. Now, of course, I'm gonna have to really tighten it so it does not let go. And you do not want to touch the positive terminal, so maybe it's safest to actually protect yourself by covering it up with something insulating. Got the other one covered up just enough to avoid a short. And now the thing that I have to do is just grab my tools and try to wrap the wire tightly around the negative terminal of the battery. Make sure I have connectivity between the... Then wrap the wire around the black jumper cable and tighten it well. Because ultimately this is going to go on the turn. So rather than rotating I can just rotate this. We're going to connect this to the cable that is... you got to make sure it's really on it and not going to slip off, otherwise you're going to lose the continuity. Okay, so here is what you have. So what you have is this is connected to the terminal you're about to remove, and it's from an area where you're not encumbering your ability to remove that battery terminal. Close these two somehow with one of these alligator clips. One is connected to the actual battery through a wire that I wired under the connection here. The other one is connected to the terminal I'm about to take off. Now, once I take that off, there's going to be still continuity between the battery terminal and this, because this is all going through here. And eventually what I'm going to do is I'm going to connect this to the multimeter. Then you loosen the black battery terminal. Okay, I've loosened it up. And technically now it should not disconnect the power. If it's done right, it wouldn't. All right, technically you can put this back here to make sure now it's connected. Battery is connected to the black, and the cable is connected to the red. And now we're going to see a little circuit with the multimeter. So we have the black one is connected to the black one, and the red one is connected to the red one. Here's a picture that shows the summary of what I've just done. So take a good look, you can pause it and follow the procedure in this diagram. Read the following warning. Do not put the key in ignition position 1 or 2, or even think about starting the car. And we're reading about 1 amp. So this thing is pulling 1 amp, probably because the trunk is open. So what I'm going to do now, try to close the trunk. They're connected to the negative battery terminal in series. And now I have these two are connected to the multimeter. And the multimeter is still reading 0.3, which I think is pretty high. And I'm going to find out why. So it takes some time for the systems to go to resting current draw. 15 milliamps, that's what I would expect from resting. I wanted to see how much amperage are these cameras pulling. Cams here, which are currently, one is off and the other one is unplugged completely. 48 milliamps, which maybe is a little bit on the high end. But there are two modules here that it measures the battery voltage, and if the voltage goes below a certain level, they cut off the circuit so you don't drain your battery. And this is on the accessory, so that's only on when you turn the ignition to position number 1. This is on battery, which means it's always on. So this is B+, so that one is always on. So if I remove that, it was reading 48 milliamps. Now I think it goes down to 38 milliamps or 39. So basically it's 10 milliamps just to run that module, maybe 8 to 10 milliamps just for that control box of the Redtiger cam, which maybe is reasonable. So now I'm going to disconnect the Vantrue module, which now that should mean that it's going to go down a little bit more. But see, the Vantrue is taking about 5 milliamps of current, which means it's a little bit more efficient in that module that measures the voltage before it cuts out the power. Okay, now it's reading 15 milliamp, and that's where I want it to be. So let's try to open the door again and close it. Now remember that there was nothing that was, there's no dome light on, so it didn't go above 0.7 amps. But now the alarm system is telling it, don't forget to lock the car, and then hopefully that will go down. It is going down. I don't know if yeah, 15 milliamp. That's the way it's supposed to be. Now let's see what it would take for the cigarette lighter adapter. Okay, now I have a cigarette lighter fuse, and now, of course, it shouldn't change anything because I don't have anything in the cigarette lighter, but I'm gonna put this FM transmitter, which I'll put later. Let me first plug this in, which is the cigarette lighter adapter. It's reading 12.8 volts for the battery, and let's see how much that's taking. Now that takes about, 7 milliamps, which I think is pretty good. So from 0.18 to 0.025, 7 milliamps for this, I could live with that. Now let's see how much that FM tuner takes. I guess I have to turn it on here. That's the FM transmitter. That's probably going to take a little bit more. And notice it doesn't actually read the accurate voltage. It says 12.4 when it's actually 12.8. This is more accurate. But anyway, now it's at 0.06 amps. So this one went up from 0.025 to 0.065, which is about 40 milliamps. Yeah. So that's, again, reasonable for a transmitter unit. And you could turn it off either from here or from the socket itself. Now it goes back to, maybe not all the way back, but to see if I turn it off by pushing the button here. Yeah, now that's interesting. Oh yeah, because there's an LED that lights this up. So if you cut the power completely to it, you're back to 25 millivolts. Okay, so now I'm gonna put the Vantrue camera with, and it's not plugged in. This is just for the controller unit here. So it's gonna pull some power, but not much. Now it's at 0.03, which is pretty good. So that's 5 milliamps of current, which is not very much, so it's not plugged in as you see, just to be able to control the voltage reading here, so it makes sure it cuts off the voltage. I think that's pretty good. Now, unfortunately, when I put this one, it's gonna go up a little bit more. So now this one is connecting the Redtiger, and now went up from 0.031 to, so I guess taking also 6-7 milliamps, which is also reasonable. Okay, now let's try to see what would happen if we do one at a time, so see how much each one takes. The Redtiger is on now, and it's recording. So now it goes from 30 milliamps to 0.3 amps, which is quite a bit higher, but it's working, it's recording, it's got the screen on. At its lowest, it's 380 milliamps, so minus 40. So you're looking at 340 milliamps, which is maybe not unreasonable. The screen is on. Maybe we can try to turn the screen off. And you go down by 40 milliamps. So now, if you subtract the 48 milliamps, you're down to 300 milliamps instead of 340. So I think it's within reason. It's not draining too much, but you'd have to consider that when you're parking your car for long periods of time. It's gonna drain your battery a little bit, especially if your battery is old. All right, so now let me try to put it in parking mode and see what that would look like. So for me to do that, I need to put the ignition key into position number 1. All right, okay, now it's in parking mode. Okay, now you can see the P, which means it's in parking mode. And now the parking mode is much more economic than recording all the time. And now it is at 330, 325, 310. So basically it's averaging at 320 minus the 40 or so of resting current draw. So you're looking at 280. So it's a little less than when it's running continuously. So it's actually drawing quite a bit of current. So keep that in mind again when you're running the parking mode. Let me try to connect the Vantrue camera. So now the Vantrue camera is on, and it's actually set on parking mode where it's motion detection. So and now it's going up to 740 minus the 40 resting milliamps. You're looking at 700 milliamps. So if you're running both cameras like I am, you're taking 700 milliamps of current. Now think about what happens when I engage the alarm in the car. So now the alarm is engaging, and it's going to take about another maybe 20 or 30 milliamps. So now I'm actually at 7, averaging at 7, maybe 40. If we, now of course what you have to do is open the door and close it to disengage the alarm. And hopefully it'll go back to 0.7 if everything is working right after it flickers for you. And it should go back down to 0.7 if everything is working right. It may take a little while, I'm not sure, but yeah, that's good. Okay, so even better. That's a reasonable draw. Now the cameras are both recording. One is recording 1 frame per second, and the other one is recording in motion detection, and it's currently recording because it's flickering, as you can see. It's the blue light's on and off, so which means it's recording, and this one is also recording. Now, let me try to shut off the Vantrue camera completely, but leave it plugged in. So what that does, it turns it into a collision sensor only. So now it's off, and it will not be recording when there's motion until it engages completely. So now you can see the good news about this is it's down to 320, which is what the Redtiger is drawing. And so but this camera is not recording in motion, even though it's set to motion, because I've turned it off. And so in the end, if you want to just undo the whole thing, close these two somehow. So now they're connected like that. Still power to the car. As you can see, the light is on in the car. Then unclip the black jumper cable. Then you're going to want to tug on that copper wire so it doesn't slip off. And then reattach the battery cable to the battery. And then detach the jumper cable. And of course, in the end, you can just undo this. So I just got myself one of these clamp meters, and I'm going to try it out to see the reading of the resting currents of these cams. So we're going to put that on 2 amps, and notice it says AC here. You want to switch that to DC, and you notice that it's reading something, so you have to zero it, but you zero it when you get close to the, you can zero it now, but you can still zero it when you get close to the line. So let me show you how to do that. This one comes from the cigarette lighter, and this one comes from another component that's always on. This is the one that's accessory, so let's test that one. That should be 0. So you zero this one, and then when you clamp it, you're going to clamp it and put that in the center of the clamp, or here's 0. So this is reading 0 milliamps. And when you go to the other ones, again, you want to try to zero it. Here's 0. Let's put that on there. Now it's reading 7 milliamps, 9 milliamps. Okay, so 7 to 9, 8 milliamps. So this is actually what we had with the multimeter that was in series, and the same with the other one, I believe. Also, it's around 5 milliamps, 7 milliamps. So there you go. You could actually put a light on there if you want, if that's any clearer. So that's about 10 milliamps, 765. So let me try to turn on the ignition and see if the accessory will pull some current. So now one of the cams is on, so the Redtiger cam is on. And what I'm going to do is I'm going to try to, and the Redtiger cam is this yellow. And let's see if there's any current going through it. We're going to 0 here. Yeah, there you go. So now it's reading 350 milliamps. That's pretty good. That's what I got with a series reading. I think that this meter is pretty accurate. So I didn't have to disengage anything really, the battery or any of that work that I did. I could just use a clamp meter. They could be pricey, but this one wasn't particularly pricey, so I'll put a link for it. So you can get something similar. And then the other one, let me try the other one. So that one is the accessory line, and 15 milliamps on the accessory line, which is well, maybe that's because it's pulling its most of its current from the normal operation, and this one is only just to get it started, I believe. So now we're trying the Vantrue, which is this line right here. So that's about 420. Yeah, so this is about what we got with the in-series multimeter. Now let's see what the total. Now I don't know if this will do the total, but yeah, it does. It does. It's doing the total 730. That's the total. So now I'm turning off the Vantrue camera. Okay, let's try the time lapse. Alright, so now it's actually time lapse. So let's see. Now that's going to be on for a while. So now that's going to be probably pulling the 300 milliamps that we expect. Yeah, it's 300. So it's not 350 because it's not, the screen is off. So it's a little bit more savings, 50 milliamp or 60 milliamps of savings. Here's another place you can tap into. So this here is your positive going from the, it's reading here 59 milliamps. This is a good resting current draw, especially considering I have at least 20 milliamps, or yeah, 20 to 30 milliamps going to the cigarette lighter that reads the voltage, and I have two modules here that constantly check the voltage. So each one of these takes about 7 to 8 milliamps. I've got 3 of these, one here, one on the cigarette lighter that's currently reading the voltage of the battery at 13. So those 3 take about 20-25 milliamps, and then the car is estimated to have about 20 milliamp draw. It's about 45 or 50 milliamps, which I think is more or less reasonable here with the consideration of the accuracy of these clamp meters. This one here is the cable that is going to, that's the cable that's going to the fuse box. This is the one that's tapping into the main supply, which is right there. That is the positive cable. So if you can get your clamp around there, you'll essentially be measuring the current on all these fuses. So there you go. I have a way to, and it's the same, should be the same as reading it off here. So if I read it off here, there's another place. Here you can see the positive thermal that comes back from the battery in the back of the car. And it got 2 main connectors. This one is the thinner gauge cable that goes to the fuse box. And this is the cable that goes, the thicker gauge cable that goes to your engine to start the, for the start of the car. And obviously wires to the alternator probably. So this one on the bottom is going to the fuse box. It's going here. Here's this one that's going to the engine to start your engine, and the other one is continuing over here. So you can tap into that one to clamp that one, or you can clamp it here as well. You get the same reading as I showed, so you can clamp that one. But you do not want to clamp the other one unless you're measuring cranking amps. Here's drawing 65 milliamps. Now let's try this monster. This is set on, this probably reads 10 milliamp resolution. And let's see if we can see what it is for this one. And now it's reading 0.05. So this is your 30 milliamp reading. 40, 50, that's what I would expect. That's pretty good. Let's measure the inrush amps. I put it at 1,000. Let's see, inrush amp. I'm going to start the car. See what that says. Wow. All right, 583 amps. That's the inrush amps. That's pretty good. That's what I would expect, something around that. This battery has about 720 EN, which is roughly 740 or 50 cold cranking amps. So we're definitely providing, this definitely provides the suitable cranking amps. And now we're at 3 amps. It's going to take a while for all the components to rest, but at least it's not fluctuating as much. And now let me try to turn off the lights, and as you see, it goes down to 1.6 amps. The alarm is going to engage a little bit, and then and we're going back to 300 milliamps, which I expect to go down to much less with time. So I'm just going to leave it for a little bit. So these are definitely pretty nifty tools to have. So this one just goes down to 1 milliamp resolution. The other one goes down to 10 milliamp resolution. I think that they're both useful. I don't think this is as accurate as 1 milliamp. I think you get about 3 to 5 milliamp accuracy at least relative to the measurements I did with the inline and the series connection of the multimeter, which is probably a more accurate measurement. All right, just like that, after about, I would say 10 minutes or so, maybe 8 minutes, I'm not sure exactly, but I'll say 10 minutes, the 300 milliamps went down to 30, 40 milliamps. As you see, it's nearly nothing now. There's no draw. So once you crank the car and start it, it's gonna engage all the components, and it's gonna take a long time for all these components to come to rest. Okay, so now I have the resting current draw. It's about 40, 50 milliamps on that unit here. And I've got another unit right here. Sorry, it's backwards, the other one. But this one is reading about 50 milliamps, which is what I would expect. So I'm gonna see what they would be when I put the key in ignition. So as soon as you open the door, it's gonna start reading measurements. So, for example, you open the door here, you're engaging all the lights, and now you have a 1.5 amps on that one, and that one is reading also 1.5 amps, as if 1.53. All right, so now we're gonna put in ignition 1.58 on that one, and here it's 1.58. Let's see what it would be when you have it in ignition position number 2. Stop the AC. So this is the position number 2 right before cranking. So let's see what that draw is like. That one's reading 4 amps. So you can hear some things, 4.4 amps. You can hear some things. So let's see here. This is 4.48. So these are very close to each other, I think. Here's the power operated soft top. So it's got fuse number 7, 43, and 49. And 7 and 43 are actually just 5 amp fuses, and the 49 is in the luggage compartment. So I think that when I was trying to operate this and look at the current the soft top requires, it was only drawing 100 milliamps, which I was somewhat suspicious of. So I'm going to try to do something different. Clearly, one way to, in addition to measuring the current draw from this positive terminal that goes to this fuse box, because obviously the other fuse that's 20 amps does not get its power from this fuse box, it gets it directly from the battery. So what I want to do ideally is put this on the negative terminal, so that essentially will measure everything that's going to the battery. So now the only problem is you can't operate the top with the trunk open, and if you close the trunk, you won't be able to read you won't be able to read this meter. So I'm going to use something else. So here's fuse number 49, and that one I believe is yeah, there it is. So that's 20 amps. And I'm very sure that that's the convertible top motors. So here's what I'm going to do. I'm going to try something nifty. Try to take advantage of the fact that I have a dash cam that is Bluetooth connected. So what we're going to do, we're going to take this Redtiger and disconnect it. And just pull it out. Let's put this clamp and put it on the 60 amp reading. I'm going to put this dash cam, connect this dash cam with the external power source. So now it's turned on. And see if I can anchor that. Here's what I have. I have the clamp reader attached to the negative terminal of the battery. So it's going to measure anything that's coming out of that battery. Right now it's reading 1 amp because the light's on here, so if I close this, it will probably read 400 milliamps, 370. At the same time, I'm taking a video of that, so I can watch it live on my phone. So my phone is going to connect to the, there it is. Now it's going to connect to the cam, and we should be able to see it live. There you go. So now you can just do that, and now we actually have the reading, and that's pretty cool. So I'm going to close the trunk now. Yeah, it is dark in there, so that's why the screen is too bright, because there's no light in there. If I throw in that light, now we have a, yeah, that's a little bit better. So now what we're gonna do, we're at 6 amps, we're gonna try different components. All right, we're in ignition mode 2, and we're gonna try to see the seat warmer. So now it's at 6 amps. If I turn on the seat warmer on full blast, it's going to about 9.5 amps. So that means it's taking 3.5 amps to heat up the seat, and if you do both seats, it's going to nearly 13, so that's another 3.5. So you're taking a total of 7 amps almost. So you go back down, turn it off, and now you go to 6 amps. So we were nearly 13, so 7 amps, 3.5 amps for each seat warmer. That's good. If I adjust the seat, engage the motors, oh, it's not looking like it's taking any battery here. Oh, sorry, it lost connection. This dash cam is not always cooperating, so we're back here. It's connected, so let me move the seat front and back. You can monitor the current draw from the image on the lower left. And when you do this, recline the seat. Wow, okay, so it does take a lot of power to operate these motors. So 5 amps for the so it takes about 5 amps for these motors. Now let's try the convertible top. I think it doesn't like being here. It keeps interrupting. So now I'm going to close the top without putting the ignition key in the ignition. Okay, so now we're seeing 3 amps, 5 amps, 6 amps, 7 amps, 10 amps, 6 amps, 3 amps. So it is pulling. The different motors do pull a lot of current. You can see it's struggling to keep the connection with my phone, but it's recorded so you can see it as it's closing the top, and different motors take different amounts of current, but the windows take the most. Alright, now the car's been resting for some time, and it's got the alarm engaged, so it's locked and the alarm is on, as you can see from the flashing LED light. And the 2 cams are actually working in parking mode. So let's see what kind of current that's pulling. I'm going to put this on the 2 amp setting, switch to DC amp, and try to 0 and see what these cams are taking. Right now they're pulling about 640 amps. That's for both of them. That's not too bad. It's pulling 270 milliamps. That's the Redtiger, and the Vantrue is pulling about 340. It's probably recording right now. And so when you do both, and both of them are, so the Redtiger is a little bit more efficient, recording about 1 frame per second. Here's a conclusion to compare the 2 methods of measuring current. Basically, the in-series measurement is more accurate, more difficult to do, and the clamp meter is a lot easier, a little less accurate, has angle issues. Here's a summary of all the components that I measured and an estimate of how much current they draw. Thank you for watching.